Hello class, this is Professor Munshi and we are in ITSY 1442 Infotech Security. Today I am going to discuss lesson 1. I'm going to use my PowerPoints and of course my verbal explanation, and I'm going to visit frequently your actual courseware in UCertify. So today, as I mentioned, we are discussing chapter 1, today's cybersecurity analyst. And my reason for coming to the courseware and showing you the pages is that way, as I explain, you will also be familiar with your courseware. And after you watch my video, it will be easier on you to study, learn from the courseware. So let's get started. The first point that we're going to discuss in this chapter is the what are the main objectives of cybersecurity? It is called the CIA triad: confidentiality, that is C; integrity, that is I; and availability, that is A. CIA: confidentiality, integrity, and availability. And what are they? What does confidentiality mean? Let's look at the courseware where we are discussing that. Go to the next page and let's see. Confidentiality, integrity, and availability. Confidentiality meaning your data, your digital assets is confidential. No one except the actual authorized users can have the access to it. It is hidden, it is confidential, it is inaccessible to all other people who are not authorized. That is called confidentiality. How about integrity? Integrity means your data, your information, your digital assets, they are unaltered, they are accurate, they are not corrupted by unauthorized people or even by authorized people. They are not altered, they are not corrupted, they are accurate. That is integrity. Third is availability, meaning people who are authorized user, whom you intend that they should have the access to the data, they will have the access and the data will be available to them whenever they need. That is called availability, meaning that data will not become unavailable at the time when authorized users are trying to access them, such as like network being down, server being down, something being going wrong, that the authorized people, the genuine people, they also are not able to access the data. That should not be the case. Data must remain available. Okay, that is the CIA triad. And you have this little exercise in here. Let's just do one. A says ensures that information is not subject to unauthorized modification. That will be integrity. Integrity meaning it is not being modified by unauthorized people. Now let's see. Ensures, number B, ensures that authorized users can access information when they are permitted to do so. It ensures that the authorized users can access, that is availability. It guarantees the data will be available. Number C, protects information from unauthorized access or dissemination. That should be confidentiality. It should remain confidential. Okay, that. Now we click on submit and we see they are correct. Go next. The next points we are going to discuss is the privacy. Let's go back to the PowerPoint. Okay, what we have in here is something called GAP, generally accepted or acceptable privacy principles. Okay, there are privacy principles to keep the data, digital assets, information private. There are information that are very sensitive. They are they are secret information. They are critical information. There are some information, they are called PII, personally identifiable information. The kind of information that will can be used to identify a person, such as their identification number, social security number, their medical history, their financial records. There are so many things, that so many different pieces of information about us that we should keep confidential. Otherwise, we may be harmed. We may be identified in the way that we don't want to be identified by the people. So let's take a look at the chapter here. Okay, what are the 10 privacy practices that organizations typically follow. One is the management. Okay, this point says that there should be clear policy regarding that about the practices this organization does regarding the private privacy, okay, your privacy of your data. So that policy should be clearly stated that it is the job of the management. Okay, second one is notice. Notice says that when a client or anyone that interacts with that organization, and that organization is collecting or storing or using that person's personally identifiable information, the organization must give a notice to that person saying how what data is being collected, how that data will be used. That should be stated properly, and so on. I want you to read all these 10 points. I don't want to go into the detail. Video will be too long. This is very easy to understand. The choices and consent and collection and use and retention and disposal, they all basically say exactly how data is being collected, how this data is going to be shared with anybody. Without your written authorization, it will not be shared with third parties. In what circumstances, who will have access to the data, when data should be disclosed, and so on. How, what measures are taken to secure your data, and so on. To be brief, so you can check this knowledge right here. PII is information that can be used to uniquely identify an individual person, which can be either on its own or in conjunction with other information. Sometimes you have some piece of information that is not enough to identify a person, but that data in conjunction with other data, will help you identify a person. So that partial data is also your PII, personally identifiable information. Okay, let's go to the next point. Now we're talking about security risk assessment. Risk assessment, what does that mean? What is a risk? And how do we assess the risk? Before we understand the risk, let's talk about three terms, two terms first: vulnerability and threat. What is vulnerability? Vulnerability means weakness. If you have a door in your at your home, in that door does not lock properly or does not have enough strong enough lock, that could be a vulnerability. Okay, if you are going outside and it's raining and you don't have an umbrella, you don't have a car, then that could be a vulnerability for you. You don't have the protection. So vulnerability means weakness. If you have a computer, you don't have an antivirus software in it, your computer is not password protected, or you have very weak password, those will be vulnerabilities in an information security. What is a threat? A threat is something that could harm you, harm your computers, harm your system, your network, your digital assets. Something that can harm. What that could be? Could be a virus, could be a malware, could be a worm, could be hackers, could be flooding, could be the extreme heat or bad weather. Okay, could be rain coming down through your roof and destroying your computer system. Anything physical, environmental, by human, any kind of risk, any kind of uh, actors, any kind of element that can harm your computers, your IT system, your business, those are threats. When threats combined with vulnerability, that becomes a risk. So it's very important to understand this. When you have both a threat and a vulnerability, that's when you have a risk. So let's understand this. Risk equals to threat times vulnerability. You are not going to put here actual numbers right here in this equation. It just means that they two have to be combined for a risk to exist. For example, if you are in a place where there is no earthquake, that never earthquake never happens, never happened in the past, and is never expected to happen. And now earthquake is a but your building that you are in, that building is not strong enough. That is not earthquake, that cannot withstand earthquake. Okay, so So you have a vulnerability that your building is not earthquake safe. Any small earthquake comes, your building is going to break. That is a vulnerability. Do you have a threat? Is the threat of earthquake existing in that location? No. So your threat is zero, but vulnerability is there, so there is no risk. Okay. So that's what I want you to understand. So either threat is not there or the vulnerability is not there, then your risk is zero. But if you have both a threat and a vulnerability, for example, you have a computer that that is not secured enough for against viruses, or even if it's secured enough, a virus could be an unknown virus, a brand new virus that your antivirus programs cannot, uh, repel. So, so you do have a vulnerability, and a threat is a virus. So in this case, you both have threat and a vulnerability. So you do have a risk. You have a risk of getting, attacked by viruses, losing your data. That risk exists. Okay, you can mitigate the risk, of course. You can mitigate the risk by installing strong antivirus programs and so on. But the risk is there. That's what I want you to understand. And regarding this risk, there is a publication by NIST, National Institute of Security and Technology. Okay, they have a publication. They have publications for all type of cybersecurity and other projects. So for cybersecurity, they have so many SP. SP means special publication. 800-30. In this particular publication, they talk about how to assess, how to identify, how to manage the risk. Okay, let's go to the chapter and see where we are at. Okay, good. So go next on that. Next coming, evaluating the risk. Okay, so we understood vulnerability, threat, good, and we talked about the NIST special publication, NIST guidelines. Okay, now identify the threats. There are different kind of threats. Okay, could be adversarial, could be accidental, could be structural, or could be environmental. Many different kinds of threats are out there. Okay, adversarial meaning some other entity, an individual, groups, organization, they could deliberately hack you or destroy your computer system, destroy your data, steal your data, get your secret, critical, confidential information out. Accidental threats, something could happen during your operation. Something could crash, a computer could crash, a software could crash, something data could be lost accidentally, somebody could delete accidentally data. Okay, structural threat, that would be like the environment that you are in. Okay, your software, your hardware, with power goes out, extreme heat, these kind of things would be your structural threat. Now, environmental threats, they are either man-made or by the environment, by nature. Okay, like flooding, the severe storms, that kind of thing we're talking about, natural disaster, or man-made, like a serious attack by a terrorist attack, for example. Okay, these are your threats. You identify the vulnerabilities. Okay, and then at the end, once you identify threat and vulnerabilities, so you found out now risk, whether you have that risk or not. Once you list how many risks you have, risk number one this, risk number two this, you have 10 different kind of risk. Then you analyze the likelihood of that risk to happen, how likely that risk is going to happen, and what is the impact in case that risk actualizes, in case that risk actually takes place. You will do that. So impact and likelihood. You're going to use a risk matrix like this one. Likelihood could be low, medium, or high. Okay, and the impact of that risk could be low, medium, or high. So if it is a likelihood is low, this is low, and if the impact would be low, then your risk is low. On the other hand, if the likelihood is, say, likelihood is high right here. This is the high likelihood up there. And your impact is medium. Impact is this way, then your risk is high. Result is high. If your likelihood is high, that's right here, and your impact is also high. So this column right here, this column intersects right here, high, your risk could be high. High and high, of course, high. So just a matrix to see likelihood and your impact of that risk. Okay, let's go to the next one. Okay, so now let's talk about that. Okay, we talked about okay, risk matrix. We just talked about that. Now, how to manage the risk? Let's talk about that a little bit. What do you do once you identify that there are some risks? What are you going to do with those risks? Are you going to take the risk? Are you going to close that particular project that's too risky? Are you going to buy insurance about that risk? So there are four ways to handle a risk. Accept the risk, meaning somebody may say that okay, you have 0.000001% possibility of a flooding in this location. Do you want to buy $10,000 a year insurance for against the flooding? You say no. I'm going to accept the risk. I'm not going to do anything about it. I take it. If it happens, happens because I think that I can handle. That's called accepting the risk. Avoid the risk is when you do not want to take the risk. You say no, this is too risky for me. So, for example, if you are buying a piece of software for this production, but that software has some issues that could cause financial loss, you say no, I'm not buying that software at all. That's cancelled. You avoid it. You don't want that anymore. Mitigate. Mitigate means you have a risk, you can't avoid it, and you cannot accept it. It's too high of a risk. Then you say, well, what can I do to reduce the risk? For example, the risk for a virus to attack our computer system, that is something you cannot eliminate all the way. Never can be eliminated, such as a risk. Fire risk cannot be completely eliminated. So what you can do, you can mitigate. For fire, you're going to have the fire alarm, you have the fire extinguisher system, everything is in place. For the virus, you're going to have the top of the line antivirus. You buy it, install it, configure it, and have antivirus on guard. These are the things you do to mitigate the risk or reduce the risk. Okay, transfer. When you give the risk to somebody else, you say, okay, if the fire happens, I have this insurance. They are going to pay us, $10 million for the loss if everything gets burned out. That is called transferring the risk to somebody else. Okay, so next. Next, let's see what we have. Identifying the risk. Okay. Now, we're talking about now network access control. So let's look at our courseware again. Okay. Next topic. What is the access control? Building a secure network. So of course, we want to secure our network. And what is NAC? NAC, Network Access Control. It is the authentication system. Nobody just all on a sudden can just walk in, meaning that is physically in the building. Why? Because you have the lock, you have the door, you have the security camera, you have the security guard in place, you have the door that is locked. Somebody has to scan their access card to get into your building. That is your access control. Same way, in the computer system, you have NAC. Okay, and as this picture right here shows, this computer right here called supplicant is trying to access to this device. This is a switch. So in other words, let me give you an example. There is an access point, meaning a Wi-Fi router. You have your laptop. You want to connect wirelessly to that Wi-Fi router or access point. What is it going to do? Isn't it going to ask you for the password? That is what I'm talking about. So in this case, your laptop, this one is a supplicant, and this one wireless access point or WAP, that is the one. Or this in this case looks like it's a wired one, wired or wireless. You physically plug in wire or you connect wirelessly. It is going to ask you password. It is going to ask you something to authenticate. But this device, this Wi-Fi, or this switch per se does not have on its own the power to authenticate. So it is called the authenticator, but it goes to a radius server. Radius stands for remote access dial in user service, radius. So this authenticator in turn takes that request to the authentication server called radius server, gets authenticated, validated, and then gives you the access. And if this server would not validate you, then this wireless router or the wired router will not give you the access. Okay. Now, looking at our PowerPoint. Okay. So authentication mechanism. By the way, this authentication mechanism works when you are actually connecting physically to the network, either with physical cabling or using the Wi-Fi. Either way, you are actually physically present in that company's network, okay, or around the company's network. You are physically pinging it. In that case, this access control that works. 802.1x protocol is a very well used, it's like industry standard for this kind of authentication. Okay, again, supplicant is the computer that is wanting to get the access, requesting the access. Authenticator is the router or whatever resource that is you are trying to access. And authentication server is the validator, the one who checks, authenticates you. Okay? Next, next one should be now right here. Okay, types of NAC solutions. Now, what are the different types of NAC, network access control? Some are called agent based and some are agentless. What does that mean? An agent based NAC is in your device. You have a little bit of software or called the agent installed. You use that little software to click in there to access the network. You request the access using that software. That's called agent based. As opposed to agentless, meaning in your laptop, in your device, you don't have an additional software for that purpose. You just use your regular web browser to connect. Then there are two other categorization of the NAC, in band and out of band. In band, when you have a device or a software or a hardware between you, meaning your device, and the actual server, actual resource that you're trying to reach. So, give an example is when we go to the hotel room and we try to connect, a little a window shows up and says enter. Even though you're connected, it shows the Wi-Fi is connected, but you cannot browse the internet. They ask you to put your room number or password, whatever, so then they will allow you to browse. Okay, so that is the in band. The out of band, on the other hand, let's look at right here for so that you can check what is going on in your actual book. Right here is in band versus out of band. Okay, so an out of band solution is your 802.1x, that is out of band, because there you are using a server. That is the difference. You are using a radius server. So wanted you to show this. I wanted you to see this, that this one is out of band, because in this case you're actually using a server, not just imagine, go back to the hotel. You're not using an authentication server, just a piece of software that is in between you and the resource. And in this case, you're actually putting username, password, whatever it is authenticated by a server. Okay, that is out of band. And NAC uses many other mechanisms other than just password, many other criteria. And let's see if I have some of those. Okay, uh, like time of the day. Yeah, there are some. Time of the day. You can configure the NAC to allow users only at certain times. You can allow the users only who have certain kind of role or where they are physically located in the world. Okay, or health of the requesting device, meaning the laptop or the tablet or the phone that is trying to connect. If that phone is compromised, if that phone is malware infected, it's going to check the health of that device before giving access to it. Okay, next. Okay, okay, NAC versus firewall. So let's talk about that. NAC again is network access control. Firewalls, what is the difference then? Well, to be very clear, NAC is going to authenticate the users who are trying to connect physically to my network. Firewalls come into place when people from outside of my network, outside of our company's network, from another company, from another place, from over the internet, coming and trying to access our servers, our network, our routers, our switches. At that time, firewalls are the one who will be authenticating them, who will be filtering them basically. Firewalls use access control list, ACL. Okay, firewalls have rules you set where based on that rule, either firewall is going to let the traffic come in, pass through, go out, or prevent them from doing so. Okay. There are some other methods we use for network security, such as network segmentation. Very important. In our network, in a company, we don't have just one segment. Sometimes by the department, the networks are segmented. By the location, sometimes are segmented. By what kind of role they play, network, different server machines could fall into different segments. For example, accounting department, management department may have their computer very secured where students or faculty members will not be able to access. Faculty members may have their resources, their network, their computer, their server located at a different segment of the network. It does not even have to be physically separated. They could be in the same room, those server machines. Still, they may belong virtually to different network segments. Each department may be protected by different rules of the firewall or different firewalls altogether. So they are segmented. They use different range of IP address because they belong to different segments. Let's talk about demilitarized zone, DMZ. Most companies have their confidential, like really secured servers only for internal use. An example would be their database server where they're keeping sensitive data. Some other server machines they are for public use. They even don't want to authenticate anybody. Anybody can just come in, such as their web server. They want people to come in and visit as many people as possible. They want to advertise their website. So now we have, so what we have two different type here. The server machines and the resources, they are only for internal use, and the servers and other resources, they are for external, for anybody's use, from outside use. So that's why you don't put those both kind of machines in the same segment. For the outside or public use machines, you create a separate segment. You call it demilitarized zone, where you have less security, less authentication, and visitors from outside, from the internet or from outside your network, they are allowed to come in. Okay, this is called demilitarized zone. Let's talk about honeypot. What is a honeypot is on purpose you are deceiving, you're tempting the hackers to come into a particular machine. That machine from outside looks like your production machine. Very important data is in there, but actually that is fake. That is not the real database that you have. That is not your real file server. That is not your real email server. Though this machine is actually is a honeypot. So but you are allowing the hackers to come in. So hackers are thinking that we got him, we got their real server machine. But why you do that? You set a honeypot to catch the hackers. That gives an opportunity to see what kind of hacking is taking place, who are the hackers, try to trace them. So you actually lure them in. Okay. Now let's look at our page here. Maybe next. Okay. Previous, we're talking about honeypot and talking about network access control. Yeah, DMZ is right here. Okay, network segmentation and defense through deception. That's when where you're going to learn about the honeypot, as I just discussed. Okay, now going to next, endpoint security. What is endpoint? Endpoint is your computer. how do you know what is who is device is endpoint and who is device is intermediate point? Okay, your routers and switch, they are not endpoint. A laptop, a phone, a tablet, a server machine, a printer, they are called endpoints. They are at the end of the network, actual machine that we use. And from one computer to communicate with another computer, you have to go through in between routers and switches. Those are not endpoints, those are intermediate devices. Okay. Now, how do we secure endpoint? Hardening the configuration. You make sure that it is configured. All your end devices, meaning your PCs, your servers, your laptops, your phones, they are configured properly. They have not been vulnerable. Okay. You use all the external software like antivirus. You use in the computer, in the software itself, whatever program you're using, say QuickBooks you're using. In the QuickBooks, you make sure you put password and everything, configure it properly, so that not everybody has all the privilege, and not just anybody can use that program. Okay, hardening the configuration. Patch management. All the computers, they require off and on, time to time, security update to be installed in them. They are called patch. They have to be regularly on time updated. Microsoft Group Policy Object, or GPO. This GPO is a very useful thing. Instead of configuring each machine separately, each of the server machines, each of the workstations separately, you just create a group policy and you configure at one time, that this will be the configuration. Then you apply that configuration to a large number of computers. So it really helps. Okay, Microsoft operating system has this feature called Group Policy Object, GPO. Okay, what is HIPS? Well, HIPS, just think of IPS first, intrusion prevention system. In this case, it's a host, H for host, meaning the end point. So a computer or a tablet or whatever your end device is, you are installing some software in it that is going to prevent the intruders from coming in. Okay, and there's HIPS. Okay, next. Excuse me. We're going to talk about penetration testing. It's a very, very important measure, step that you take to secure your network. Yes, for your security, time to time, you arrange penetration testing, so that you actually hire either your internal either you use your internal IT security team, who will be specially tasked for this penetration testing. So they are going to try to penetrate your network from outside the company, but they are your employees, they're internal people, and they are trying to hack in the system to check whether systems are hardened enough, secure enough, whether whether your system can be easily compromised. Or you hire external people. That is most normally people do. You hire an external team, the kind of team, they actually sign a contract with you that they are going to legally, officially try their best to hack into your network, to your server, to your resources, and you pay them to do that. Okay, so let's talk about that. There are four phases of the pen test. That is in NIST documentation described in 800-115 special publication of NIST. It describes the standards for penetration testing. Okay, there are four phases: planning phase, discovery, attack, and reporting phases. Okay, what happens in the planning phase? Once you are contracting an external penetration testers, they are going to plan. You're going to write documentation about what? Timing, scope, and authorization. What it means? What does it mean? What it means is this: when exactly they will run the penetration test, exactly when it begins, when it ends. Beyond that time frame, they could not hack your system. They could not penetrate. They could not do anything to you, because that will be against the contract. That will be illegal for them. That becomes an illegal activity. Scope, exactly who is part of your system, who is machines or who is segment of your network, exactly what software, what production facility they are going to hack. So what is in the scope and what is outside of the scope clearly defined. Authorization. That will say who authorizes this team. If one of your internal employee or somebody thinks that somebody is hacking in and they start taking action against them, they're going to say, no, we are authorized. We are officially hacking in your system because we are authorized. We are penetration testers. That authorization has to be there. Okay. Now next, the discovery phase. Once the planning is done, planning phase is done, a contract is signed, everything's clear. That's very important part. Then the penetration testers are going to go to the discovery phase. In the discovery phase, they're going to run reconnaissance. They're going to collect as much data as they can. They're going to scan your machines security from outside. They're going to try to use all kind of software to find out, map your network, exactly how your network is set, how which machines are where, if they are vulnerable, which ports are open, which ports are listening. They are going to find out all those things. They're going to map the entire network software wise from outside. Attacking phase, that now that they are ready, they already know, they have learned how your network is set, where your server machines are, what kind of firewall you have, what are your vulnerabilities are. They already found that out. Now they're going to exploit the vulnerabilities. They're going to attack, actually hack in. And at the end, the reporting phase, they are going to submit a report. They're going to communicate the report very clearly to you that, hey, we ran the penetration test. These are the vulnerabilities we found. These are the high risk, these are the low risk, whatever. They're going to say, these are the things that you need to fix. These are your vulnerabilities. Okay. In a penetration testing, the red team, they are the attackers. The people who are attacking, they are called the red team. People who are defending, setting all the defenses, they are the defenders. They're blue team. Okay, blue team are the defenders, and white team are the referee. If these two teams, have complained or they are not getting along or they are doing something not right, then the white team will say, "Hey, this is the rules of engagement. This is the rule of the game. Okay, that this team has the right to do that. This other team, no, you don't have the right to do that." So the referee are the ones that are the white team, okay? The management particularly, whoever is for the management role, holding the management role for the penetration testing. Okay, now let's look at the chapter right here. Okay, so here are the four phases: planning, discovery, attack, and reporting. And at the end, you will be doing your red team, blue team, done, go next. Okay, reverse engineering. Reverse engineering is a very important concept. Engineering, typically what you do, you build something, right? You find the components, you put them together, and you build a finished product. Reverse engineering is the opposite. You are given a finished product and you are going to undo everything. You're going to break it into small pieces. You're going to go backward to find out the what kind of components are there, how it was built, what was the purpose. Okay, like if you are given an airplane and you want to learn how to build this airplane, so you start taking it apart and know, you start learning all the parts and components. That will be reverse engineering. Reverse engineering. Okay, in the cyber security, this is an important concept. Sometimes there are software, they are malware, and you want to analyze them more. You are suspicious about them, but you don't quite know. So you want to reverse engineer them, find out their codes, their source code, their binary code, their, to use a decompiler to convert them into the source code and to see whether they seem to be harmful. Okay, what is sandboxing? Let's go to our PowerPoint. Okay, we're going to talk about sandboxing. Let's talk about advanced persistent threat, APT. Okay, these are powerful actors like state actors who has a lot of money, like Russian uh, cyber attackers. Okay, hackers, American hackers who are hacking maybe Russia's system. So they have lots of resources and they customize. They have the time, resource, and the expertise to make very, very difficult, very um, sophisticated kind of threat, kind of malware, kind of technique that they devise to hack very highly secured other opponent systems. They are called advanced persistent threat. Those actors are called the threat. Okay. Now, what is sandboxing? Is an isolated or a safe environment. An isolated or a safe environment where you can actually put a malware or a suspicious malware and actually execute it and see how it is working. Whether it's truly a malware and what kind of harm it may do, you learn about it without harming your network. Because the sandbox is again a safe and isolated environment. That's what you're testing, your reverse engineering of the of your malware. Okay. Now talk about decompiler. We just I touched a little bit. Decompiler converts executable programs back into source codes. So you can look at their source codes. Okay, that helps you identify. So now we're probably at the end of the chapter. So let's go next and exam objectives. Okay, summary. Okay, so good. That was your chapter one. So now that I was able to explain the chapter and hope that this video helps you. Now that you watch this video several times to get the key concepts properly understood, it's going to help you study the chapter and learn more. Okay. And of course, always ask me questions if you have any, and have a wonderful day.